Geotechnical Engineering, Part A, Soil Mechanics. As you can see here, developing of only 1 centimeter of clay soil occurs in a matter of almost 800 years to create just a centimeter of a clay soil. That's how slow the process is. Before everything, let's jump to three phases of soil diagram. So if you look at a configuration of a mass of soil, there are a kind of the soil body, water bubbles, mhm, and also some kind of trapped air inside uh, the, the the main body of soil. So or the structure of soil. So if we want to show a representation of what we do have in a soil, that's a three phases of soil elements, and that's air at the top, water in the middle, and the main body of soil. And at the top left we have a volume of air, volume of water, and volume of soil. That's the volumetric elements. And at the right, that's a weight of air, which is almost close to zero. We consider it to be zero. Weight of water and weight of soil. Mhm. That's a three phases of soil diagrams. We derive all of our relation based off this a diagram. So if you remember from physics, that's a unit weight, or gamma is a mass over the volume. Sorry, weight over the volume. So that's a gamma and goes by a unit weight of material, whatever you have. So if we want to know what is the unit weight of a soil in total, that's a total weight over total volume. So in a weight volume relationship, in it the total weight is weight of air, weight of water, weight of soil, and this one we definitely talk about it, and that goes by a zero because that's almost close to zero. And the denominator shows the volume for soil plus volume of water and plus volume of air. Definitely air eh, occupied some space, but for the weight we consider it to be zero. And the other things that is that we consider a volume of air and water to be called volume of void. And that's void between the soil structure. And at the right, we do have again, this is a likewise weight of void. Mhm. So one can say we can call weight of soil plus weight of water, that's a W of void, and this part at denominator, that's a volume of void. Mhm. I had it in a better format, so that's a weight of water plus weight of air, which is zero. It's consists of weight of void, and likewise at denominator, their volume together is volume void, as we talk about it. Mhm. And if we just consider the unit saturate unit weight, it just says instead of having water at the middle, just fill all the air space also with water and call that W water prime or V W prime of it's because we have W of water. It's better to call it W water prime. So that's additional water which goes to uh, the space which is allocated for initially allocated for air. And likewise, you can call that VW prime. That's why it's not V prime W, that's VW prime because we do have a VW. This is another uh, uh, W which enters to the space which is initially it's not uh, supposed to be for water. That's for air, but for saturated scenario, water fills everywhere. All the void is filled up with the a water. Likewise, a unit weight of soil is just weight of soil over volume of soil. That's unit weight for soil. Mhm. And at the end, these are just some kind of very common and very useful definitions of uh, soil mechanics equations. So that's a gamma dry. Dry unit weight is a just weight of soil, weight of soil, this time over the total volume. So that's a gamma dry. Just consider the uh, weight of soil divided by the total volume of the structure, three phases diagram. So that's a some definition which consists of W total, a gamma total, when you have a for example, a percentile saturation of soil, when you have gamma saturated, when you have a fully saturated condition, and you have gamma soil, just consider the grain of soil over the volume of soil, and again, the weight of grain of soil over the volume of total, that's a gamma dry. Mhm. That you can easily see gamma dry is way below gamma soil in most of the cases. And finally, we can have a gamma prime, which is a gamma saturated unit weight minus unit weight of W. And we call that a submerged unit weight. Gamma prime goes by a submerged unit weight. That's gamma prime. Mhm. We'll review them over and over many times in the course of this semester. Mhm. And now let's a flashback to physics. Rho density is mass over volume. So let's see what is the difference between a rho and gamma. Uh-huh. Density and unit weight or a specific weight. And gamma is called unit weight or a specific weight, and that's mass over volume. So if one can just simply connect the dot, that's a m times g. Uh-huh. This is mass over volume, then goes by density. Mg, which is weight over volume, goes by unit weight or also a specific weight for your material. We're talking about soil here, so that's for soil. Mhm. And again, that's a mass, and this is weight. That's the difference between density and a unit or a specific weight. So in SI unit, gamma WW is just a 10 kilonewton hour meter cubed, and in US customer unit, that's a 62.4 pound feet cubed. Mhm. If you want to know what the exact numeric value for gamma water in SI unit, that's 9.81. kn cube meters, and that's almost 10 kn. So we just go by 10. And if you want to know that in kilogram over cube meters, that's 1,000. And if you want to know that in ton over cube meters, that's 1 ton cube meters. Just in case. And you can do the same for a pound cube feet. Mhm. So they are easily convertible to each other. And just in case to have a comparison of them, just in case gamma of water is 10 kn over cube meter, and gamma for a concrete is my bad, that's a 24. Gamma of concrete is just a 24. That's how you can see the relation between a how gamma concrete is a higher than gamma of water, and with what order is higher. That's a 10, that's 24. Let's see a range of a different gammas. Mhm. So in to have a better understanding of them, the smallest is a gamma prime, which is in the range of 7.5 and up to 11.5 kn cube meter. That's all in SI units. That's smaller than, that's the smallest. Gamma prime is the smallest, and gamma soil is the largest. And that's a smaller than gamma dry, which is in the range of 30.5 to 19. And that's also a smaller than total gamma, which is a something like a uh, 50% saturated, 40%, 20%, 90%, but not completely saturated. And that's in the range of gamma is in the range of 50.5 to 19.5. And that's smaller than gamma fully saturated. That's for example, for gamma total, you can have something like 0% saturation up to not zero, just something like let's go by one. It could be any number higher than zero, because if it's zero, that's go by gamma D. And 99.9 percentile, that's a gamma total. Mhm. And then gamma saturated is in the range of a 70.5 kn over cube meters to 21.5. And gamma soil is between, just for the grain part, is between 23 to 28 kilonewton cube meters. And if you compare that number make a comparison between gamma water, which is 10, and gamma concrete, my bad, that's again 24. That's again a 24 kn over. You can easily see that even the loosest grain are something about they are a small, if there is a negligible difference between the loosest grain soil and concrete, and that's a most of them are almost higher than even concrete. That's how the soil is stronger than even concrete. Mhm. If you're talking about only the strength of the grain and forget about the void ratio, because if you include them, it just goes by something like a from this much or way lower than concrete. But just the grain size has a huge importance in the structure. Mhm. So let's define some more terms, and that's a GS. That we call that specific gravity, and that's nothing by a division of unit weight of whatever material you have over a unit weight of water. And we can show that by GS, SG, or G sub S. So that's GS is, for example, in soil, that's GS is a stand for, that's a specific weight that goes by a unit weight of soil over unit weight of water. And if you remember from previous slide, a unit weight of soil is 2.3 up to 2.8, If you divide it by a, you just show it this way, over 1, it was 10, we just have it 23. And it was just just have it by 1 by unit, that's 2.3 to 2.8. And in that sense, GS for concrete is this time 2.4. Mhm. Just forget about the unit, just make a comparison to see how they are related to each other. And that's a concept of specific weight, or sorry, a specific gravity. Specific weight is gamma. Hmm? So let's define the void ratio, the spaces, empty spaces in the soil structure. We define void ratio. Void ratio is just shown by E, and that's volume of void over volume of soil. So that's volume of void. Uh-huh. That's void ratio. Volume of void, which is a summation of air and water, and that's volume of void over the volume of soil itself. So definitely you can see void ratio can be smaller or bigger than 1. If soil percentile or a portion is bigger, it can be smaller than 1 because your denominator is increasing. If the total of these two is bigger than the volume of your soil, a void ratio definitely increases more than 1 because the ratio of this area, this volume over this volume is definitely bigger than 1 if they are equally distributed in volume. And the other term is porosity of soil structure, and that's shown by N, and that's volume of void over the volume total. So this time porosity, which shown by N, is just volume of void, summation again of volume of air plus volume of water, this time divided by total volume. So one can easily say porosity is all the time smaller than 1. You can never have a chunk of something bigger than the total of that. So that's why the porosity is all the time a smaller than 1 in any kind of scenario. Let's do the conversion of porosity, the relation of porosity and a mm, uh, void ratio, and then we'll follow up our discussion in next video. Uh, Porosity is volume of void over total volume, and you can show it like this: volume of, keep the volume of void at a numerator, and expand the denominator by total volume is void volume plus a soil volume. Mm? And if you just reverse the uh, mm, your process, it's just 1 over n is just it just denominator comes to numerator, that's VV plus VS over V volume void, and that's 1 plus, if you just see this is, one can easily say this is 1, and VS over VV is 1 over a void ratio. So one can easily say porosity is equal to E over 1 plus a E or void ratio over 1 plus void ratio. Likewise, if you do that for a this time void ratio, this is void ratio, that's porosity, mhm, and that's VV over VS, volume of void over volume of soil. And you can just this time expand the a that's my bad. That's V total volume. You can expand the denominator, and that's volume of T minus volume of void, because a volume of This is volume of void, volume of total minus a volume of void. That just goes by volume of soil. That's what we have here. And if you do the mass, it just reverse the process. That's again volume of T minus volume of V. Mhm. And it just gives you this time a void ratio is just n porosity over 1 minus porosity. That's how we can convert these relation to each other. Let's see what else do we have. We just have a air percentile. So we do have a chunk of air trapped in the soil body. So that's a percentile of air is volume of air over total volume, and that's multiplied by 100 to gives us the air percentile or percentage of the air inside the soil structure. Thank you. We'll derivate more equation and relation of geotechnical engineering in coming session. Thank you.